Hello everyone, thank you for joining us today. My name is Jenny and I'm a part of education team at Medit. Nice to meet you everyone, and today we have Dr. Kim here.
Hi, Jenny, and welcome everyone. It is a pleasure to be here. How are you, Jenny?
I'm good. Thank you for asking. What about you?
I'm also doing great. As I have picked the webinar topic about 3D setting, I tried my best to collect all the clinical cases about edentulous in my daily practice so that I can come up with good content.
Wow. So today's topic is digital techniques for determining VD in edentulous patients. And the topic about VD setting is king of the both part when it comes to the full mouth restoration. So I think there will be so many people want to get a clinical tip about VD setting, especially when it comes to digital way.
Yes, right. It is hard to set it accurately when a patient has lots of both arches, and there are a few more considerations when it comes to restoring in a digital way.
Wow, I see. I think there will be so many dentists waiting for this content more than any other one. Let's get it started.
Welcome to today's lecture on the innovative approaches to acquiring vertical dimension in Edentulous patients using digital methods. Today's session focuses on blending traditional and digital methods to determine the vertical dimension in dentistry. We're going to explore how integrating these techniques can enhance accuracy and efficiency in our dental practices. Here's our agenda. We start with the traditional methods which are foundational in dental practice, understanding their core principles and the potential enhancements. We then discuss digital integration with three innovative approaches. First, we have the centric tray and nathometer M, which helps us capture bite positions digitally, streamlining the process and minimizing manual errors. Next, we explore Professor Quan Tay No's method, which uses off-the-shelf products designed for measuring vertical dimension and centric relation at the initial visit. For our third approach, we will discuss a modified version of Professor No's method, where an individual tray is used to acquire the final impression, vertical dimension, and centric relation all at once. Our aim today is to give you a clear understanding of how these methods can improve precision and efficiency in your practice. Let's get started. Let's dive into the detailed process of determining the vertical dimension for dentures, a critical step in ensuring optimal function and aesthetics. Patient evaluation. We begin by assessing the patient's facial aesthetics and anatomical features. We also review any pre-extraction records and photographs. These initial assessments help guide our restoration plans. Use of physiological rest position. We measure from the tip of the nose to the chin while the patient is relaxed. This gives us the vertical dimension at rest, or VDR, which is foundational for our next steps. Estimation of occlusal vertical dimension. From the VDR, we subtract about 2 to 4 millimeters to accommodate functional occlusion. This adjustment is essential for comfort and effective mastication. Use of phonetic methods. We then have the patient pronounce specific phonetic sounds, like S sounds, to bring the teeth close together. This helps us accurately fine-tune the vertical dimension. Trial denture setup. A trial denture is created to evaluate aesthetics, phonetics, and functionality. The patient wears this trial to assess comfort and usability, providing us with valuable feedback. Adjustments based on feedback. Based on the patient's feedback and our observations, we make necessary adjustments. This step is crucial for achieving the best fit and function of the dentures. Finalization. Once the ideal vertical dimension is confirmed and the patient is comfortable, we finalize the denture. This ensures that the denture fits well and functions optimally. We're examining how modern technology revolutionizes the process of denture fabrication, starting from initial impressions to the final product. Let's delve into each component of this digital transformation. Digital scanning. Digital intraoral scanning has replaced the use of alginate for obtaining preliminary impressions. This method captures precise digital impressions of the patient's oral cavity quickly and comfortably, minimizing errors and reducing the discomfort associated with traditional methods. It's particularly effective for duplicating existing dentures, providing a base for necessary adjustments. Computer-aided design. With digital impressions available, we utilize CAD to design and visualize dentures with remarkable accuracy. The ability to easily design custom trays and implement techniques like Gothic arch tracing enhances productivity by facilitating rapid design changes and ensuring precision in both temporary and final denture production. 3D printing. After finalizing the design in $3 D printing is employed to create the denture. This technology accelerates the production process and allows for easy replication and modification of dentures based on feedback, significantly reducing material waste and overall treatment time. Feedback loops. The integration of digital tools enables dynamic feedback loops. As patients test their dentures, precise data on fit and functionality is gathered. This data is then used to make any necessary adjustments in the CAD software. The revised design can be quickly reprinted for further testing, ensuring that the dentures are optimized for comfort and functionality before finalization. By harnessing these technologies, we not only streamline the entire process of denture fabrication but also enhance accuracy and improve patient satisfaction, marking a significant advancement in prosthetic dentistry. In the intricate process of crafting dentures, 3 foundational steps are paramount to achieving a successful outcome: final impressions, vertical dimension, and centric relation. Each of these elements plays a vital role in ensuring that the dentures fit perfectly and function optimally for the patient. Final impressions. Precision starts here. Final impressions must capture the exact contours of the patient's oral structures, providing the detailed groundwork necessary for designing dentures that fit seamlessly. Without accurate impressions, every subsequent step risks inaccuracy, affecting the overall fit and comfort of the denture. Vertical dimension. Determining the correct VD is crucial for the aesthetic and functional integration of the dentures with the patient's facial features. It affects how the patient looks and functions while wearing the dentures, influencing everything from chewing efficiency to facial expressions. Centric relation defines the optimal relationship of the jaw in a 3-dimensional space, detailing the anterior, posterior, and lateral position of the lower jaw to the upper jaw. Identifying accurately is essential for ensuring that the dentures will allow for the most effective bite and natural jaw movement, preventing issues such as joint discomfort or uneven wear on the denture. While these elements have historically been challenging to achieve using analog methods, today we are poised to introduce how digital technologies are transforming these critical steps. Through the application of digital solutions, we can significantly increase the productivity and efficiency of clinical practices. In today's lecture, we will demonstrate 3 specific examples of how digital technologies are applied to enhance these critical aspects of denture fabrication. In our first case study, we explore a hybrid approach that combines both traditional and digital methods to achieve optimal results in denture fabrication. Let's break down each step used in this process. Preliminary impression. We began with an intraoral scan, replacing traditional physical impression materials. The intraoral scanner provides a digital map of the oral cavity, offering a fast, accurate, and comfortable way to capture preliminary impressions directly from the patient's mouth. This method is particularly advantageous for its precision and ease of use. First, intermaxillary relation, for establishing the initial relationship between the upper and lower jaws, we used a centric tray. This traditional tool is crucial for accurately recording the base-jaw relation before moving on to more detailed adjustments. Final impression: a 3D printed individual tray was utilized for the final impression. Custom designed and printed for the patient, this tray ensures that the final impressions are extremely accurate, capturing detailed nuances of the oral structures, which are essential for crafting a well-fitting denture. Vertical dimension and centric relation: to determine the VD and cur, we employed the nathometer M. This device is highly effective in accurately recording the vertical dimension and the centric relation of the jaws, providing precise data that guides the final adjustments in the denture's fabrication. When scanning the maxillary arch for edentulous patients, ensure the intraoral scanner's smart color filter is turned off to accurately capture the delicate soft tissue details. Begin with stable regions like the hard palate, moving towards dynamic areas while maintaining a consistent distance and angle with the scanner to capture the full arch. For the mandibular arch, it's just as important to disable the smart color filter for clarity. Start scanning from immovable tissue areas and proceed to the more flexible regions. Special attention should be given to capturing the buccal and lingual sulci accurately, as these are critical for proper denture fit. Both processes require careful scanning of the alveolar ridges and the buccal and labial vestibules, ensuring all pertinent anatomical features are clearly recorded for the subsequent design and fabrication of the denture. The use of a centric tray in edentulous cases begins with the clinician positioning it within the patient's mouth to record the preliminary vertical dimension and jaw relationship. The tray is equipped with impression material, and the patient is guided to bite down, allowing the material to capture the contours of the edentulous ridge. This provides an initial estimate of VD and a starting reference for centric relation, which is then refined through subsequent appointments to reach the final. In this video demonstration, we show the scanning process of a centric tray that has captured the impressions of both the upper and lower arches of an edentulous patient. The procedure starts by scanning the impressions in the tray to get a digital record of the bite registration. After the initial scan of the impressions, we focus on scanning the lateral sides of the tray. In this video demonstration, we guide you through the process of aligning the scan data of an edentulous patient's upper and lower jaws using a centric tray. The key step shown is the inversion of the tray scan to correctly align the mesh directions of the scans. This crucial technique ensures that the upper and lower jaw scans are perfectly matched in orientation. In previous video, we demonstrate how to capture the interarch relationship for edentulous patients using a centric tray and oral scanning. We enhance this process by employing a simple yet effective intermediary cotton rolls, which serve as a bridge connecting the upper and lower jaws. By adjusting the thickness of the cotton rolls, we set the vertical height, placing them strategically between the arches. The nathometer M is an advanced tool used in dentistry to precisely determine the centric relation and vertical dimension for edentulous patients. It features adjustable components to capture the patient's optimal bite position. To use the nathometer M, the dentist fits the device to the patient's mouth, then instructs the patient not only to bite down but also to move their jaw forward, backward, and side to side. This procedure tracks all directions of jaw movement, enabling the nathometer to accurately determine the jaw's centric relation. In this video, we demonstrate how to design an individual tray compatible with the nathometer using Medit software. We begin by launching the Medit design software and importing upper and lower jaw models. After virtually extracting teeth and smoothing the areas, we proceed to Medit's splint design application to set the insertion direction and adjust the interior offset to the maximum 0.5 millimeters while minimizing others to avoid retention features. We then draw and finalize the splint margins. The same process is repeated for the mandibular model. Afterward, we run Medit design again to combine the splint with the jaw scans, adjust the rim mesh by referencing facial scan data, and remove any extraneous flat areas. By adding a 1 mm offset to both jaws and subtracting from the rim offset, we complete the integration of the rim and splint. The final step merges the splint and rim to complete the tray design. This slide visually details the progression from design to assembly of a dental device. On the left, the top and bottom images display the 3D printed individual tray created as previously described. The center images capture the tray after attachment to the nathometer illustrating how the components fit together. On the right, we see the complete assembly, showcasing how both components integrate to form the final setup used for capturing precise dental impressions. In this video, we demonstrate the process of taking impressions using an individual tray for denture fabrication. Initially, adhesive is applied to the tray to ensure the impression material adheres properly. We then apply a heavy body impression material around the borders of the tray for the primary impression, capturing the detailed contours of the edentulous area. Following this, a light body impression material is spread over the entire surface of the tray for the secondary impression. This two-step process ensures a comprehensive and precise capture of the dental anatomy, resulting in a detailed and accurate final impression. In this video, we demonstrate setting the vertical dimension and determining the centric relation using the nathometer. We begin by attaching the nathometer to the setup and adjusting it by turning the screws to set the appropriate vertical dimension. Once the vertical dimension is set, we proceed to adjust the mandible by moving it forward, backward, and side to side. This maneuver helps us accurately determine the centric relation.
Thank you for sharing all your tips with us, Dr. Kim.
My pleasure. I hope everyone had enjoyed the webinar.
Yeah, for sure. So let's move on to Q&A sessions. So today we have 4 questions. So I'll start with the first question. Question number 1. Are there any key parts to be considered when restoring an edentulous case digitally?
When digitally restoring an edentulous case, it is crucial to use high-resolution scanners with care, especially when capturing the moving soft tissue to ensure precision in the field of dentures. For restoring jaw relations, digital methods can be more cost-effective as they often do not require the purchase of additional traditional tools and equipment. Additionally, the use of computer-aided manufacturing allows for the effective and precise production of dentures.
Okay. Okay, question number 2. What is the clinical tip when setting VD in digital way?
Traditionally, setting the arbitrary relationship often involves using bite trays with special bite materials, but a simpler and more patient-friendly alternative involves using cotton rolls. These cotton rolls effectively stabilize the jaw in the desired position temporarily and act as a bridge connecting the upper and lower jaw scans. This method facilitates the measurement process without specialized equipment, enhances patient comfort, and simplifies the procedure. Additionally, for accurate sensory relation determination, custom trays can be designed digitally and produced using 3D printing. This ensures a perfect fit, making the process quicker and more accurate, and allows for individual trays to be created on demand, significantly advancing the method of establishing precise jaw relations for setting the vertical dimension.
Wow, using cotton roll seems really a clinical tip.
Yeah,
Okay, question number 3. If you're making a bite rim with 3D printing, do you think digital bite rim can be replaced with conventional wax rim?
certainly, when using coding anti-tracing to establish your relations, individual traits that incorporate this feature have effectively replaced the function of the traditional wax rim.
Wow. Okay, last question. Question number 4. Is there any specific process in the conventional way that is still essential and can be replaced with digital method when restoring an edentulous case digitally?
Oral scanners struggle to accurately capture the mobile soft tissue areas, particularly the length and thickness of denture border. Directly moving to final dentures without using intraocclusal records or trial dentures to confirm vertical dimension and centering relation can result in inaccuracy and necessitate post-publication adjustments. The materials using in 3D printed denture often raise concerns about their long-term durability and strength. Additionally, milling process can face issues with artificial teeth detachment and lower productivity in manufacturing.
Thank you for clarifying all the questions that are prepared for today. Okay, that's all about it for today. So you'll be able to watch this webinar on our YouTube channel and Medit Academy once it's completed. Thank you for being here, Dr. Kim.
Thanks everyone to joining us today. Hope to see you at our next webinar. Bye.
Bye.